Hello. Hi everyone. Good morning, good afternoon, good evening everybody. Welcome back to the tutorials of SAP ABAP on HANA training series. Thank you for choosing JK Tutorials. So in today's class, we will see some important features of SAP HANA, like code to data paradigm, data compression, parallel processing, and OLTP and OLAP. So let's get started with the code to data paradigm. So what is code to data paradigm? So here you can see this is our application layer. This is our database layer. Okay. So using SAP HANA specific features which you have seen such as like columnar databases. We have seen like SAP HANA is a column store database. Okay, in-memory database. Okay, columnar databases, compression and parallel processing requires a developer to consider new ways of designing and implementing both existing and new applications on the in-memory database. Okay, so this brings us to the code to data paradigm, which can ensure that our application considers SAP HANA's features to deliver applications with massive real-time data processing capabilities. Okay, so in the traditional programming, encourage developers to keep loads away from the database. So in our traditional databases, how the database works, how the process was happening. So in traditional programming approach, that encourages the developer to keep loads away from the database layer. Okay, all the calculations part are done at the application layer. Okay, so applications were designed to retrieve all the data needed at once. Okay, and complex calculations and operations were then performed on the internal tables in the application layer. For example, we want to fetch the Mara table record. So firstly, we will fetch all the Mara table records into our application layer, and if we want to do any processing, any calculation in that record, all the processing we do at the internal table at application layer. Okay, this recommendation is important when a traditional database is used. Okay, since database hardware is not capable, okay, of processing massive data in real time. So in those traditional databases was not capable to process all the data, huge data. Okay, so this also leads to performance issues as data retrieval can be very slow. Okay, however, when the in-memory database like SAP HANA, the recommendation to move the code away from the database becomes less important. Okay, instead it's recommended to push more of the load of expensive calculation, data processing, and mathematical operations to the database layer. Since SAP HANA's capabilities and features enable applications to process data in real time. So after we came up of HANA DB. Okay, what happened? All the calculations part, usually all the calculation part are to be done at database layer. Okay, as just we have seen. So with an in-memory database, which is like SAP HANA, recommendation to move code away from the database becomes less. So previously all the data firstly we have to fetch at the application layer, then we have to do the processing. But now at database level only we can do the all the processing. So for the greatest performance, our developer's goal should be to bring back only the required details to the application layer. So to the application layer, all those details which are only required, those details only to be fetched at the application layer. Okay, rather than moving a much larger volume of intermediate data and then calculating the details in application layer. So it's talking about traditional databases where all the data is fetched to the unusual data fetched to the application layer and all the calculation are done there. But now only the use or like whichever data is important, that data is to be fetched right there. Okay, fetched to the application layer. So the code to data paradigm inspires application. Okay, so the code to data paradigm inspires application developers to use SAP HANA specific features and capabilities that assist in designing optimized applications for real-time data processing. The application logic required to perform complex data operations such as calculations, aggregation, and text processing is moved down to the database layer. All the calculations here, okay, to the database layer by implementing one of the many techniques available. Okay, is it fine? So if you will see the definition of this, what is portrait data figure in one line is basically a programming style in ABAP where you code to push down data intensive computations and calculation to the HANA DB layer instead of bringing all the data to the ABAP layer and then processing the data to do computation. Hope it's clear. Let's move to the next feature, which is data compression. What is data compression? The column store table allows the efficient compression of data. This makes it less costly for SAP HANA database to keep data in memory, and it also speeds up searches and calculations. Okay, so in SAP HANA, there are two types of data compression. One is data dictionary compression, and second is advanced compression. What is dictionary compression? Dictionary compression is a default method of compression and is applied to all the columns in table. Okay, it involves the mapping of distinct column values to the consecutive numbers so that instead of actual value being stored, the typically much smaller number is stored. Okay, so another is advanced compression. What is this? Each column can be further compressed using different compression methods, namely prefix encoding, run length encoding, cluster encoding. Okay, so the SAP HANA uses a compression algorithm with which type of compression is most appropriate for column. So in this course, we will see only dictionary compression, which we will cover. Okay, now just take an example. Okay, here in this table, you can see the sales information in different countries of these products. Okay, Tata Motors in India, Ford, Mahindra, Jeep, Mercedes, Kia. Okay, so as we know, this is the sales information. So as we know, SAP HANA by default use dictionary compression to compress all the columns in table. For that purpose, it creates a dictionary which holds the distinct values in particular column. It creates some, one second please. It creates some dictionary. For example, here the dictionary holds all the distinct values in the column country. Okay. So for this column country, this dictionary table contains all the distinct values. For example, here you can see 1, 2, 3. Okay. So for India, it has given the value ID as 1. For United States, it has given value ID as 2. For New Zealand, it has given value ID as 3. Okay, when we save this data into database, instead of saving all those actual values as like India, United States, New Zealand, okay, we will save its value ID only corresponding to those values in the database. So you can see here, okay, as a place Y, here you can see, once again, in the compressed column, you can see here position 1 value ID is 1, position 2 value ID is 2, position 3. So you can see it's got replaced by value IDs. The value here position is 1, 2, 3, 4, 5, 6. At position 1, what is there? It's India. So we have put in the value ID as 1. So at position 2, it's United States. So we have put it the value ID as 2. At position 3, it's India. So we have put it the value ID as 1. At fourth position, it's again United States. So we have put it as 2. And again, its position value, sorry, at position 5, it's India. So we put it as the value ID 1. At the last, it's New Zealand. So we put it new value ID as 3. So this is the compressed column. Okay. Similarly, in all those processes, okay. So you must be wondering why we are not directly storing the actual values, but we are storing the value IDs corresponding to the actual IDs, actual values in database. This is because for each character we required one byte. Similarly, if you want to save complete column country, it will take multiple bytes. Okay, so for example, so this is our so if you want to save all those countries, if you want to save all those details into our database, what is the size for this? So this will take 5 bytes. US will take 13 bytes, India again 5 bytes. So then how much total bytes it will take? It will take total 52 bytes. But if we are storing these reports using compressed column, here you can see it will totally take 24 bytes if you are storing our reports using value ID, and if you are storing our reports with the same name, it will take the 52 bytes. Okay, so here you can see the difference. The difference may be more if the length of the data in column country will be more. SAP HANA is so intelligent that it directly works on compressed columns, not on actual columns. So this is how data compression works in SAP HANA. Is it fine? So benefits of data compression is like it reduces the amount of memory required. Here you can see it will require only 24 bytes. It will require 52 bytes. Okay. It speeds up the operations on columns because the columns can be loaded into the CPU cache faster than fewer loading cycles. So it obviously speeds up the operations because for processing the numbers is easy in comparison for processing these values, characters. Okay. And it provides a very cost-effective method of managing large data sets. So this is how we get benefited by SAP HANA future data compression. So is it clear? Okay. So next is data compression. What is sorry. So next is parallel processing. Okay. So one of the key enabler of SAP HANA's incredible performance is parallel processing. With the recent hardware development, special new multi-core processor, okay, we can build instant responsive applications by spreading the processing tasks across all the cores. Across all the cores, SAP HANA automatically spreads the workload across all the cores, okay, and ensure that all the parts of hardware are contributing to the throughput. SAP HANA is a scalable means you can easily add more processors as required to increase the parallelization and therefore the speed of processing. Okay, to take the advantage of built-in parallel processing capabilities of SAP HANA, you can use column store tables. Column store tables are automatically processed in parallel. Each process can be processed by one core. So each columns can be processed by one core. And you can see all this can be processed by one core. So this is what parallel processing is. Okay. Hence, more cores you will add, more cores you add the SAP to the SAP HANA landscape, the more parallelizations occurs. Okay, even the same column can be split up, processed by different cores at the same time. For example, here we have the same record, so this same column can be differentially split up into the different cores. Okay, is it clear? So now let's move to the OLTP and OLTP. OLTP, we have listened it multiple times by OLTP, OLAP. OLTP is online transaction processing. OLAP is online analytical processing. The terms we are often confused for one another. So, what are their key differences, and how can we choose the right one for our situation? Okay, so OLAP. So OLAP, online analytical processing. This one is a system for performing multidimensional analysis at high speed on large volumes of data. Large volume of data means previous 8 to 9 years of data. Okay, typically this data is from a data warehouse, data mart, or some other centralized data store. OLAP is ideal for data mining, business intelligence, and complex analytical calculation, as well as business reporting functions like financial analysis, budgeting, and sales forecasting. So next is which OLTP. So OLTP, this enables the real-time execution of large number of data transactions by large number of pupils. Typically over the internet, OLTP systems are behind many of our everyday transactions, from ATMs to in-store purchase to hotel reservations. Okay, OLTP can also drive non-financial transactions, including password changes and text messages. So OLTP is real-time data, which usually works on real-time data. OLAP is which works on past data, like historic data. Okay. So what is the purpose? It's for transaction processing. It's for OLAP is for analytical processing. Okay. What is for database structure, for OLTP is normalized and for OLAP is denormalized. Okay. For query complexity, OLTP works on simple query of individual reports, but it works on complex queries involving aggregations and analysis. The concurrency is high concurrency for simultaneous transactions, lower concurrency focus only on analytical processing. Okay, quick and efficient for processing, for transaction processing. Okay, it's for query performance for analytical processing. Okay, for data operation, it will work on inserts, updates, deletes. Basically, it works on read heavy operations, aggregations, and calculations. Okay, emphasizes on maintaining data consistency and integrity. It maintains the data consistency. It focuses completely on providing accurate and consistent analysis. Okay, so inside OLTP, data is current data only, like for about 5 to 10 months data. OLAP historic data for about 3 to 8 years. Okay. Some examples are order processing, inventory management. Okay. And OLAP is business intelligence, data warehousing, reporting, or you can say if okay. So it's clear OLTP and OLAP. Okay. So that's all for this today's session. Thank you so much. Thank you for joining. Thank you. Bye.